One question that you can ask is also, are threads useful on a single CPU? Or even more generally, are threads useful when the number of threads is greater than the number of CPUs? To answer this question, let's consider a situation where a single thread, T1, makes a disk request. As soon as the request comes in, the disk needs some amount of time to move the disk spindle to get to the appropriate data and respond to the request. Let's call this time T idle. During this time, thread 1 has nothing to do but wait. So the CPU is idle and does nothing. If this idle time is sufficiently longer than the time it takes to make a context switch, then it starts making sense to perhaps context switch from thread 1 to some other thread, T2, and have that thread do something useful. Or specifically, rather, we need the execution context that's waiting on some event to be waiting for an amount of time that's longer than really 2 context switches, so that it would make sense to switch to another thread, have that thread perform some operation, and then switch back. So basically, as long as the time to context switch, T context switch, is such that T idle is greater than twice the time to context switch, it makes sense to context switch to another thread and hide the idling time. Now, this is true for both processes and threads. However, recall from the last lesson that we said that one of the most costly steps during the context switch is the time that's required to create the new virtual to physical address mappings for the new process that will be scheduled. Given that threads share an address space, when we're context switching among threads, it is not necessary to recreate new virtual to physical address mappings. So in the threads case, this costly step is avoided. For this reason, the time to context switch among threads is less than the time to context switch among processes. The shorter the context switching time is, there will be more of these T-idle situations when a thread is idling, where it will make sense to context switch to another thread and hide the idling time. Therefore, multithreading is especially useful because it allows us to hide more of the latency that's associated with I/O operations, and this is useful even on a single CPU.